Hello, it's Sean again, and I'm going to look at AQA GCSE Maths Foundation Tier. It's a paper 3 from the practice set 3 releases. So this one again is a calculator paper, and so do have your scientific calculator ready. Feel free to skip to questions you're struggling with by looking at the description in the comments, and you can go straight to the questions you want to work through rather than having to sit through the whole video. So let's have a look anyway at the first question. Question 1. Solve 3x equals 12. Circle your answer. Well, this one you need to be finding pretty straightforward really. That one is x equals 4. 3x just means 3 multiplied by x. So 3 multiplied by what number would give us 12? Out of all these, it's got to be 3 times 4. So if x is 4, 3 times 4 equals 12, which makes the equation work. Question 2. Circle the ratio which is the same as the scale that 1 centimetre represents 2 metres. So we need to remember our metric measurement. So 1 metre is the same as 100 centimetres. And so essentially to change from centimetres to metres would be a scale factor of multiplying or dividing by 100. Effectively, you need to know that a metre is 100 times bigger than 1 centimetre. And so if 1 centimetre represents 2 metres, and we know that 1 metre is 100 centimetres, if we multiply by 2, that tells us that 2 metres is 200 centimetres. And so we can think about this one, 1 centimetre representing 2 metres, we can think of in this way. And if you put it all in terms of centimetres, it's the same as saying 1 centimetre represents 200 centimetres. Now we're talking about the same units, so it's easier to compare. And we can do that because we've just worked out that 2 metres is the same as 200 centimetres. So that becomes much easier. 1 centimetre on the map, or whatever it might be, is the same as 200 centimetres in the other conversion. So this is going to be a 1 dot dot 200. Because this thing on the right hand side is 200 times bigger than the thing on the left hand side. Question 3, work out 3/7 multiplied by 2. So if it's a calculator paper, then why not just use the calculator? 3/7 multiplied by 2, we can just do that as 3 over 7 multiplied by 2, which a decent enough calculator will tell you straight away is 6 over 7. And so that's the one we should be circling. Just to let you know, if it was on a non-calculator paper, any whole number can be made into a fraction by considering it as a whole number over 1. A fraction means a top number divided by the bottom, and 2 divided by 1, or any number divided by 1 for that matter, stays as the number itself. And so 2 can be thought of as 2 over 1. And from there, we multiply fractions by just multiplying the top numbers together. 3 times 2 is 6. Multiplying the bottom numbers together. 7 times 1 is 7. If it simplifies down, simplify it. If it doesn't, which this one doesn't, we leave it as it is. And so this one, multiplied by 2, is 6/7. Question 4. An ordinary fair dice is thrown with a circle for probability of getting a number greater than 4. And so numbers on a dice, I'm just going to list here. We could have a 1, a 2, 3, 4, 5, or 6. And the numbers which are greater than a 4, there's only 2 numbers which are greater than a 4, which are 5 and 6. And so 2 numbers on a dice out of 6 are greater than 4. And 2 out of 6, we can write up as a fraction as doing 2 on top of 6. 2 over 6, which will simplify down to 1/3. And again, a decent calculator should be able to do that for you. Type in 2 over 6, press equals, and we would get 1/3. And so that's the one we need to be circling. Question 5, that's a little 3, that means the cube root of a number. And there will be a button on your calculator for doing this. Essentially it means what number multiplied by itself 3 times gives us 4096. It is not the same as this. So don't do 3, press the square root button, 4096. That's a big mistake. That's a little 3, which means a root. This is a big 3, which means 3 multiplied by a square root. The answer isn't that. What you need to do is shift and then press the button above the square root symbol. So this thing here is now the same as what we've got in the question. Now we type in 4096, press equals, and we get the correct answer of 16. And so the cube root of 4096 is 16. The cube root is the opposite of cubing a number, just to let you know. So 16 cubed is 4096. But going back to the original question, our answer is 16. And so 16 is what we've put on the answer line. Part B, work out 3 to the power 7. That means 3 multiplied by itself 7 times. And so that's 3 to the power 7, 2187. Question 6. Gino has opened a pizza restaurant. Good for him. Wish him luck. The frequency table shows information about the first 20 pizzas he sells. We need to complete a pictogram, including the key. And so a pictogram just means we're going to use pictures to represent the data. And we can use any key we want to. And so each circle could be 2 pizzas, could be 10, but keep it simple if possible. If we have a look at these numbers here, these numbers are small and manageable. So what I'd suggest is the simplest key I can think of is that each circle represents just 1 pizza. And so for margarita, if we've got 5 margarita pizzas, if each circle is 1 pizza, 5 pizzas, we need 5 circles. Pepperoni, 8 pizzas, so we need 8 circles. Six, 7, and 8. Salami, 3 pizzas, so 3 circles. And finally, vegetable, 4 pizzas, so 4 circles to finish that one off. Part B, it asks us what percentage of the 20 pizzas were pepperoni. And so pepperoni, we've got 8 pizzas. And as the question says, there's 20 pizzas in total, which it does say as well here. So based on that, we can say that 8 out of 20 were pepperoni. So 8 out of 20 we can write is a fraction easily enough. And then a fraction, any fraction, can be converted to a percentage by multiplying it by 100. And so 8 out of 20 pizzas were pepperoni. Multiply that by 100, and what we should find is that 40% of pizzas were pepperoni. That could well be a question on a non-calculator paper actually, since the numbers are quite easy to work with. So we just need to put that 40% of his first 20 pizzas sold were pepperonis. 6C is a special offer now. So the special offer says 1/3 off the price of food. So the price of food isn't 1/3 of what it normally is, it's 1/3 off. So the reduction is going to be 1/3. So food was £13.50 on Ruth's order. Pay special attention to the fact that the offer doesn't include drinks. So don't be thinking you can take a third off of drinks, because we can't. And so what we need to work out here is a third of £13.50. A third of £13.50, we can work out by just doing £13.50 divided by 3. Or we can use a fraction button and do the fraction multiplied by the amount in question, which is 13.50. And that gives us £4.50. And so we need to take this off, which means we need to subtract this discount from the total food price. And so the food offer price, if you like, the discounted price for the food with this offer, is £13.50 minus £4.50, which would come to exactly £9. So after the voucher's been used, 15% service charge is added. And so the total for food and drink the subtotal is now £9 for the food on offer. The drink is full price because the offer excludes discounting the drink. So £9 plus £2.40 would give us a subtotal of £11.40. Now what we need to do is work out the 15% service charge. So 15% service charge is added to the subtotal of everything. So if a bill comes to £11.40, we then add on 15% of £11.40. So 15%, which means 15 over 100, of £11.40, we can work out easily enough on a calculator. So 15% means 15 over 100, and multiply by the amount in question, and we get £1.71. So the service charge is £1.71. It does say the service charge is added, so the final total is the £11.40 subtotal. Now we're going to add on the £1.71 service charge. And so the final grand total is £11.40 plus £1.71, which comes to £13.11. And that's a grand total that Ruth needs to pay. Therefore, that's our final answer, £13.11. Question 7. We've got this ice cream, and who doesn't love a bit of ice cream? Well, maybe if you're lactose intolerant, I suppose. But anyway, we've got 2 tubs of ice cream that cost £5.90, and we need to work out how much 5 tubs would cost. So, looking at this one here, we can start by just saying what the question says, really. That 2 tubs is £5.90. What we can do, which is easy enough, is just work out the cost of 1 tub. So how can we go from 2 tubs down to just 1 tub? What could we divide 2 by to get 1? Well, any number divided by itself gives us 1. And so if we divide the number of tubs by 2, we can divide the cost of 2 tubs by 2 to work out the cost of just 1 tub. So each tub of ice cream will be £5.90 divided by 2. Oops. Which is £2.95. Then once we know the cost of 1 tub, we can just multiply that by how many tubs we need. So what the question's asking us for now is how much 5 tubs cost. So we can just multiply the cost of 1 tub by 5. And if we do that to the number of tubs, we need to do the same to both sides. So multiply both values by 5. So 5 tubs will be 5 multiplied by £2.95, which should give us a total price of £14.75. So that'd be £14.75 worth of ice cream. Part B, we've got a factory that makes 8,000 tubs of ice cream. Each tub contains 500 millilitres. And so if we've got 8,000 tubs being made, and each one has 500 mils inside it, that's a total of 8,000 multiplied by 500 millilitres. That's a lot of millilitres. Let's work out just how many. So 8,000 multiplied by 500 comes to 4,000,000. That's 4 million millilitres. But here, emphasis has been put on the units we wanted. We're wanting the answer to be in litres. And so to change from millilitres to litres, again we need to know our conversion factors. We need to know that 1 litre is the same as 1,000 millilitres. So this is a conversion relationship where one of the numbers is a 1, and the other number isn't 1. And if we have a conversion factor in this form, we can change from one unit to the other by multiplying or dividing by the number that isn't 1. So in this case, we're going to be multiplying or dividing by 1,000. So to change from litres to millilitres, we're going from a small number to a bigger number. So that way around, we'd be multiplying by 1,000. But to go the other way around, from millilitres to litres, if we go the opposite way around, we'd have to do the opposite thing, which would be to divide by 1,000. So in this case, because we want to work out the answer in litres, we need to change from millilitres to litres. So to do that, we take the number of millilitres we've got and divide it by 1,000. So if there's 4 million millilitres, we can take and divide that by 1,000 to find out how many litres that's the same as. So I'm just using this conversion factor here to help us. It's going to highlight where the 1,000 came from. So 4 million divided by 1,000 comes to 4,000 litres. And so that's the final answer for how much ice cream this factory is making in a day. Question 8, we're trying to work out Zoe's password, which I don't know is allowed in data protection regulation, but anyway. So it's made up of 4 different digits. She remembers it as 2 different 2-digit numbers. And so the first thing she says is that the first 2-digit number is a prime number between 10 and 20. So let's try and think about what this number could be. So it's a prime number between 10 and 20. So think of the primes between 10 and 20. 11's prime, 12 isn't because we can half it, 13's prime, 14 isn't, 15 isn't because we can divide it by 3 and 5, 16's not prime, 17 is, 18 isn't, 19 is. And so these are all the primes between 10 and 20. And the second two-digit number, she says it's a prime number between 10 and 30. So let's think of possibilities for this one now. So all the primes between 20 and 30. 20 isn't prime. 21 isn't either, because 21 we can divide by 3 and 7. 22 isn't prime because we can half it, but 23 is. 24 isn't. 25 isn't because it's 5 squared. 26, nope. 27, however, is not prime, because 27 is the same as 9 multiplied by 3. So it's tempting to think 27 is, but 27 isn't prime. 28 isn't, because we can half it, but 29 is prime. And so there are two primes between 20 and 30, which are 23 and 29. And so all her possible password combinations, well, the first number could be 11, and we could have 23 with it, or we could have 11 and 29. So looking at 13 now, we could have 13 and 23, or we could have 13 and 29. So as long as we list these systematically, we shouldn't be making any mistakes. 17 and 23, 17 and 29, and finally 19 and 23, and then 19 and 29. So if we do this systematically, there should be very little risk of losing one out or making a mistake. And so there should be 8 possible different passwords. And so we just need to list these numbers on the answer line. So 1123, 1129, 1323, 1329, 1723, 1729, and the last couple 1923 and 1929. And that's all of them. Question 9. The house is being built and 8,400 bricks will be laid. So there's a total of 3 different bricklayers doing it. Each one's going to lay 350 bricks per day and will be paid £115 per day. How much in total will they be paid? And so we can work out the total number of bricks being laid per day. This is a type of question where there's quite a few ways of doing it. So the only thing I'm interested in really is if you understand your way of doing it, or mine, and we arrive at the same answer and can agree on that. So total bricks laid per day is the way I'd tackle it first. So each builder can lay 350 bricks, but because there's a total of 3 different bricklayers, we can multiply that by 3. So 350 multiplied by 3 is 1,050. Bricks per day. But we need a total of 8,400 bricks to be laid. And so if 1,050 bricks can be laid per day, how many days would we need to lay 8,400 bricks? So 1,050 per day. How many days would we need to get up to a total of 8,400? So what we could do to do this directly would be to divide 8,400 by 1,050. 8,400 divided by 1,050 comes to exactly 8. And so what that tells us is to lay 8 times as many bricks, which is how many we'd need 8 days. So those 8,400 bricks could be laid in 8 days. So 8 days are needed. And so for one builder, eight days work, he'd be owed 115 per day, because that's how much you get paid per day, multiplied by the number of days he or she's working for. So it'd be 8 multiplied by 115. Which comes to a total of £920. So for all 3 builders, if each one's paid £920 for the 8 days which is needed to complete the work, then 3 of them will be paid £920 multiplied by 3, because it asks in total how much will they be paid. So 920 multiplied by 3 is 2,760. So that's how much money will have to be paid out to the bricklayers. £2,760. Question 10. Work out the highest common factor of 15 and 20. Factors just means what fits into a number. So what can we divide the number by with no remainder? Well, any number can be divided by 1, which gives itself. 15, though, can also be divided by 3, which is 5. So these are all the factors of 15. Factors of 20, again, 20 can be divided by 1, which gives itself. We can also divide 20 by 2, which is 10. Finally, we can divide 20 by 4, which gives us 5. And so this is all the factors of 20. So what we need is to identify the highest common factor of these two different numbers, the biggest number that divides them both. So what's the biggest number we can see in each list? The biggest number we should see in each is 5. So the highest common factor of 15 and 20 is 5. A little trick I'd suggest you try and use is, if you're looking for the highest common factor between two numbers, always just check the difference between the two numbers you're checking. The difference between 20 and 15 is 5. And so the highest common factor between any two numbers will also have to be a factor of the gap between them. And often, the highest common factor will be the gap itself. Not always, but often. So it's always worth just checking that for an easy way in. Difference between 20 and 15 is 5. That's the highest common factor. It won't always be, but it's always worth checking just in case, because if it does work, it's just an easy way into answering the question. This is the way I've done it here is the slower way, but it's the safest way. But always check the gaps just to see if there's a quicker way. 10b, work out the lowest common multiple of 6 and 8. All this means is the smallest number which is in the 6 times table and the 8 times table. And so let's just list them. So 6 times table, the first number is 6, and 12 18, 24, 30, 36, and so on forever. The 8 times table starts with 8. 8 times 2 is 16. Multiplied by 3 is 24. Multiplied by 4 is 32, 40, and so on and so on. And so the lowest common multiple, the smallest number you can see in each list of the 6 times table and the 8 times table is 24. And so the lowest common multiple of 6 and 8, for that reason, is 24. Question 11. We have a frequency tree to fill in. So 240 people go to a rugby match. 183 people support the home team. That bit's been filled in for us here. So each time a number branches with a frequency tree, the 2 numbers it branches into will always add up to the number they branch from. So this one plus this one will always add up to 240. And so we can work out the number of away supporters by doing 240 take away 183. And if we do that, 240 subtract 183, we get 57. So 57 people were away supporters. It also says that 162 of the supporters are male. And so 45 male supporters are away supporters. So we can make out the number of male home supporters by doing 162 subtracted from this 45. So the number of male home supporters will be 162 subtracted from 45. So if we try that, 162 minus 45 of 117. So there'll be 117 male home supporters. And as I said before, each time a number branches into 2 with a frequency tree, the two numbers the number branches into add up to the number those numbers branch from. And so this one here will be 183 minus 117. And so 183 minus 117 is 66. In the same way over here, 57 supporters were away supporters, 45 were male, and so the other 12 were female. And so that's a frequency tree completed. Question 12, you need to work out the remainder when 8,529 is divided by 42. And so if we do that on a calculator, 8,529 divided by 42 equals 203.0714. So it's 243 whole times we can fit 42 into 8529, and this little bit here represents the remainder. So 203.0714, and so on. So the way to interpret that would be 203 and a bit. That decimal part is a bit, and that is going to be the remainder. And so what we can do, because 203 42s fit inside 8529, we could work out what 203 multiplied by 42 is. So 203 multiplied by 42 is 8526. The remainder just means what's left. And so if we do 8529 take away these 203 42s that fit inside it, which comes to this, we can find out how much is left. In other words, what the remainder is. So 8529 take away 8526 gives us a total of just 3. And so the remainder is 3. And that's our final answer for question 12. Question 13 is about Harry buying his yogurt, and he buys it on the 27th of June 2017. How many days after Harry buys the yogurt is the 13th of July 2017? I'll admit something to you, and it's slightly embarrassing for me. I can't really do these questions unless I write the dates out one by one. I don't know why, it's just a mental block I seem to have, so I'm going to do it this way with you as well. What we need to know as well, though, is that June has 30 days. 30 days have September, April, June and November. So June has 30 days, and so we can start from the 27th and count all the way up to the 13th of July. So here's a table I made earlier, which is something you could jot down in the exam to help you. And so it says how many days after he buys yogurt is the 13th of July. So if he buys it on the 27th of June, if he buys it on Venn, that's 0 days after the date he buys it. 28th is 1 day after, 29th is 2 days. So if we build it up all the way along, going into July here, the 13th of July would be 16 days after. And so that's what we need to write down. It'd be 16 days after he buys it. Part B, there's some information on the pot, and he tries to work out the amount of sugar in 100 grams of the yogurt. His first answer is 61.65 grams. Why must this be wrong? If you have a look, it's a 1-mark question, so there's likely going to be a fairly straightforward trick to this. So he gets 61.65 grams for the amount of sugar in 100 grams of the yogurt. But if you have a look at the packaging, the total contents is 450, and in this entire tub there's only 75.15 grams of sugar. And so if he's getting 61.65 grams, that must be impossible, because that's more than the amount of sugar in the whole tub, the whole pot. So if we just write down something similar to that, his answer is more than the total sugar in the entire pot. So obviously it can't be possible. He's done something wrong. Part C. So he tries to work it out again, how much sugar is in 100 grams of yogurt. He tries his calculation now. What error has he made? I always find these kinds of questions quite difficult because it's hard to see someone else's errors at first. What I would suggest to do is to work it out the correct way yourself and then compare your correct method to this presumably incorrect method. And so if the content is 450 grams, that relates to 75.15 grams of sugar. So 450 grams of yogurt. I forgot what it was then for a second. I guess 57 0.15 grams of sugar. We want to work out how much is in 100 grams of yogurt, so we're not interested in 450 grams of yogurt. What we want to do is work out 100 grams. Well, what we could do first of all is work out the proportion of sugar in just 1 gram of yogurt per gram. So, to go from 450 grams to just 1 gram, we can divide 450 by itself. Remember, any number divided by itself will give us 1. But if we divide this side by 450, we need to do the same to this side here and divide this by 450. And so in just 1 gram of yogurt, we'd have 57.15 divided by 450, which is 0.127 grams of sugar. Then once we've worked it out for 1 gram of yogurt, we can just multiply by how many grams we're wanting. And so the question's asking 100 grams of yogurt. So we can go from 1 gram to 100 grams simply by just multiplying by 100. So if we multiply both sides by 100, we could find out how much sugar is in 100 grams of yogurt. So 0.127 multiplied by 100 gives us 12.7 grams of sugar. And so if we compare what we've done here, we took 57.15 divided by 450 and then multiplied by 100. So if we compare what we've done, which is the correct method, to what Harry's done, we can see the error, and it's at the beginning bit. Instead of doing 450 divided by 57.15, he should have done 57.15 divided by 450. So he's got these two numbers the wrong way around. So he should have done 57.15 divided by 450. Not what he has done, which is 450 divided by 57.15. So something to that effect would get you the mark. Now part D says work out the correct amount, which we've already done. Well, I've already done it in part C. So it'll be 12.7 grams of sugar in the complete yogurt, sorry, in the 100 grams of yogurt. So we just need to write that down. Another way, just to quickly mention to you, we could have worked out the proportion of sugar in the yogurt by thinking of the sugar as a fraction of a whole yogurt. So there's 57.15 grams of sugar out of a total 450 grams of yogurt. And so that gives us fraction. Now we can change from a fraction to a percentage by multiplying by 100, which gives us 12.7. So that means 12.7 grams is sugar out of every 100 grams of yogurt. 100%, 100 grams. So 12.7 would be our answer, thinking of it that way. Question 14. X is a whole number greater than 1. We have to circle the word that makes the following sentence correct. X is something of x squared. And so how do we get x squared from x? Well, x multiplied by x equals x squared. In the same way, for example, that 6 multiplied 2, just picking these numbers at random, would give us 12. So 6 and 2 would fit into 12, and so these would be factors of 12. Factors of 12 include 6 and 2. Also you have 1, 2, 3 and 4 and 12 itself, but you can think of factors as a number as not only what divides into the number, but also one factor multiplied by another will give us the number. And so in the same way, x is a factor of x squared, because x multiplied by itself would be x squared. For example, if we were to think of x as 3, 3 times 3 would be 3 squared, which is 9. And a factor of 3 squared is 3. So in the same way, a factor of x squared is x. Just makes it that bit harder when it's mentioned in terms of algebra. If it were actual numbers, it'd be much easier to think of. That's why I've tried to relate it to actual numbers for you. But x is a factor of x squared, so we need to circle the word factor. Question 15. In a game, Anna has to describe a hexagonal prism. She must not use the words hexagonal or prism. So hexagonal prism. The first thing we're going to do is to show you an hexagonal prism. Hexagonal prism means it's got 6 sides in hexagon at the top and bottom. Or if it were laid down on its side, it'll look like a hexagon at the front and the back. And so if any shape's a prism, one of the defining characteristics about a prism is that it will always have a uniform cross-section. If you slice it at the bottom, at the top or the middle, it'll look like a hexagon all the way throughout. So that isn't a mistake. One thing she says though is it has 6 faces. So a face is each flat part of the shape. And so what I've got here is a little animation to show you how you can picture this. It wouldn't have 6 faces. Let's see how many it would have. If you count these up, this is how it starts, and you can imagine it being unfolded. You'd have 1, 2, 3, 4, 5, 6, 7, 8. There'd be 8 faces, not 6. And so we can say that it's got 8 faces, not 6. As that little diagram shows us. I'll just get rid of that because it might be a bit distracting, but hopefully it makes it clear why it's got 8 faces. You might be able to count them from the diagram I've just drawn below as well. And vertices are corners of the shape. So again, what we could do is count up the corners. So vertices are just where the edges join. So I've got 1 here, 2, 3, 4, 5 and 6. So I've got 6 at the top, and also as well there'd be 6 vertices at the bottom of the shape. 6 plus 6 is 12, and so that again is right. It does have 12 vertices. Now edges are the straight bits which join the vertices together. And so if we count these up, just starting at the bottom, that's 1, 2, 3, 4, 5 and 6. There's 6 vertices, sorry, I mean 6 edges, I apologise, at the bottom. 6 straight lines that join all the corners of the bottom. Let's have a look at the top now. The top it'd be the same as the bottom. There's 6 edges joining each of the vertices at the top together. And finally, there's another 6 edges joining the top to the bottom. There's a 4th one, a 5th one, and finally the 6th one. And so in total, we've got 6 plus 6 plus 6, which would give us a total of 18 edges. And so that's her second mistake. It doesn't have 12 edges, it has 18 edges. Edges, not 12, like she says. So there's 2 mistakes she's made, 2 marks for mentioning both mistakes correctly. Question 16, we've got a Venn diagram, and we can use it to describe this school trip, which is about trips to Austria and France. So 63 students go to Austria, so if we call this circle here the circle for Austria, A, this circle over here, F for France. 89 students go to France, 15 students go to both Austria and France. And so on a Venn diagram, if they go to both countries, Austria and France, that's represented on the Venn diagram by the overlapping section of the diagram, which should be this purple bit I'm just colouring in here. The fancy word for the overlapping bit of A and F is called the intersection. But 15 students, if they go on both trips, they would fall within both circles. The bit that is inside the circle for Austria and France is this overlapping part here. 54 students don't go on either trip, and so if they don't go in either trip, that means those numbers of students don't belong in either circle. And so we need to put 54 inside the rectangle but outside of both of the circles. So looking at Austria, it says 63 students go to Austria. Of those 63 that go to Austria, 15 of which also go to France. And so the students that go to Austria alone and not to France will be 63 minus 15. And so we can work this out here. 63 minus 15 is 48. So of the students that go to Austria, 48 just go to Austria, 15 go to Austria and France. 48 plus 15 gives the 63 we require. And so the students going to Austria we can think of as the students falling inside this circle here. H&N students go to France as well, it says. Now the students go to France are the students in the circle on the right hand side as I've drawn it. So of the students that go to France, 15 of them go to both France and Austria, and so the other students that only go to France must be 89 minus 15. Which is 74. So how many students are there in year 10? This will be the total of all these students. The total of all the students in year 10 that go on a trip, plus the students that don't go on the trip, must add up to the total number of students in year 10 combined. And so if we total up these 4 values, 54 plus 48 plus 15 plus 74, that will tell us how many students there are in total in that year group. So 54 plus 48 plus 15 plus 74 comes to a total of 191. And so there are 191 students in year 10. Question 17. There's a solid shape that's made with a cube and a cylinder. So the cube has an edge length of 3 centimeters, and the cylinder has diameter 1 centimeter and height of 3. The first thing we need to do here is to draw the front elevation on the centimeter grid below. The front elevation just means what the shape would look like if you look at it from the front, from this arrow. And so what we would see looking at it from the front would be the square front bit of the cube, which should be 3 by 3. So looking at it at the front, we would see this cube like so. We'd also see the front bit of the cylinder. Now looking at it straight on, I'm just going to colour in for you what you'd be able to see to hopefully make it a tiny bit clearer. So we'd see this front bit of the square, and sitting on top of that square we would see just the front bit of the cylinder. We'd only be able to see the width of the cylinder, so we'd be able to see 1 centimeter across it. So looking at it straight head on, the cylinder would just look like a rectangular shape. It'd be 3 centimeters high and 1 centimeter wide. And so looking at it head on, we'd see in the middle of the square something like this. So there's the square with the cylinder sat on top of it. Part B, we need to draw the front elevation and side elevation on the centimetre grids below when the cylinder's laid flat. So if the cylinder's laid flat, this 1 centimetre diameter will now be from here to here. And so it will be now 1 centimetre high on top. So looking at it from the front, as we were before, we would see from this angle and from the side we'd be looking at it from this perspective. So if we colour in what we see from each side, from the front, we'd see the square side of the cube, and we'd also be seeing this bit of the cylinder, which should now be just as long, exactly as long as the cube, because it was 3 centimeters high. The cylinder will now be 3 centimeters along, which is the same length as the cube. And because it's laid on its side, it would now just be 1 centimeter high. So for a viewer looking at it straight on from the front, it would appear to be like a rectangle, 3 centimeters along, 1 centimeter high. And so what these shapes would look like would be like this. So the cube would look like just a square from the front, and the cylinder would just be sat on top of it like this. But from the side, what we'd see would be slightly different. From the side, we'd again see the same square face, because each side of a cube will look identical because each side of it, each face of the cube, is the same size square. So that one would be the same. But from the side, we wouldn't see the green part of the cylinder I've coloured in from the front. What we'd see would be just the circular end. Now the circular end has a diameter of 1 centimetre, and so what we'd see would be the same square, like so, but then sat in the middle of that square, on the top of it, we'd see a circle, a circular end of diameter 1 centimetre. So the circle we'd see at the end would be of that size. And so that's what it would look like from the front, and that would be the side view of this shape. Question 18, we have a formula, S equals 5t squared, where S is the distance in meters a ball falls when dropped, and t is the time taken in seconds. So for part A, we're told a ball is dropped, and 1.2 seconds later, it hits the floor. What distance does the ball fall? Well, what we can do here is just a simple substitution into a formula. So S is the distance the ball falls. So we're asked for the distance, we're asked to work out what S is. And so S is 5 multiplied by the t, the time, squared, and t is a time in seconds, which again, we're told, is 1.2 seconds. And so in our case, S, the distance, equals 5 multiplied by 1.2 squared. So because the time is 1.2 seconds, the distance is just 5 multiplied by 1.2 squared, which should be easy enough to do on a calculator. So 5 multiplied by 1.2 squared equals 7.2. So the distance the ball fell was 7.2 meters. So we can just fill that in on the answer line. Now for part B, we've got a different ball that's dropped from 2 meters above the floor, and we need to work out the time taken for this ball to hit the floor. And so there's two ways of thinking about this one. One way could be to rearrange the equation, so t comes first, because we want to work out the time this time. So if S equals 5t squared, then we can work out what t squared is by dividing both sides by 5. Again, if we swap this 5 to the other side, we swap side, we swap sign. And so t squared would be S divided by 5. And the opposite of squaring something is to take the square root. And so t will be the square root of S divided by 5. And so we can just substitute in now the value into our equation. So just get rid of that. So S stands for the distance, and we're told it's fall from 2 meters above the floor. We want to work out the time, which is t. So t will be the square root of the distance it fell, which is 2, over 5. And so if we just put these values into the calculator and see what happens. So type in the square root, we can even do a fraction within a square root, 2 over 5, press equals, and we get 0.6325, so 24555 and so on. If you're not sure what to round it to, just write down all these digits on your calculator, but if you are a bit more comfortable with rounding, a sensible degree of accuracy would be perhaps 2 decimal places. For example, your stopwatch on either your watch or your mobile phone, your smartphone or whatever, should tell you a time to within 2 decimal places. If it's a particularly good one, it'll be 3 decimal places, but 2 decimal places would be sensible. Not unless you've got the most accurate time measuring equipment in the world could you measure down to this accuracy. So 0.63 seconds would be sensible enough. I'm just going to show you another way you could have thought about that problem using a flow diagram. So the formula we've been given is for S. So we want to work out the time in this case. So whatever we're wanting to work out, we can start with. So in this case, start with t for time. And just think what's happening to t on every step. So just remember BIDMAS. Powers come before multiplication. So the first thing that happens is that t gets risen to the power 2. So t gets squared. So the first thing that happens to t is it gets squared. That gives us t squared, and then we multiply that by 5, which gives us 5t squared. And 5t squared tells us the distance, which is s, which in our case now is 2. Using this way, we can start at the end, go the opposite way, doing the opposite things each time. So if we start at 2, going backwards, instead of multiplying by 5, because we're going the opposite way, we do the opposite thing and divide by 5 instead. And so 2 divided by 5, we can check on a calculator. We can either leave it as 2/5 or write down 0.4. So each stage, just make a little note of what it is at that stage. 2 divided by 5 is 0.4. And then going backwards, instead of squaring it, we're going to do the opposite of squaring something. The opposite process of squaring a number is to take the square root. And so t will be the square root of 0.4, which we can work out here. Square root of 0.4 again gives us 0.63. And so using this different method again, we'd arrive at the time being 0.63. Doesn't matter which way you use, as long as you're comfortable in understanding one of these 2 different methods, and as long as you can arrive at this answer for t. Question 19. We have 2 right-angled triangles, and for part A, we're to assume that both triangles are similar. And we need to work out the area of triangle PQO. And so PQO is a triangle that goes from P to Q to O. So I'm just going to shade this in to make it less likely you'll get confused by which triangle I'm talking about, because there's 2 different ones here. Sorry that I'm not a very fast person at colouring in, but just bear with me, I'll be done fairly quickly. Okay, so these 2 triangles are mathematically similar, so we're told to assume. So that means that one triangle can be considered as an enlargement of the other one. And so this is obviously the bigger triangle. So what we can do is compare the dimensions of the smaller one. So the smaller triangle, smaller triangle, from B to the origin x goes from -3 at B to 0 at the origin. And so the distance going from one corner to the other of a smaller triangle is 3. And so the base of this smaller one is 3. The height of it, again using the similar idea with the coordinates, we start from y being 0 and we go all the way up to where y is 4. And so if y goes from 0 at the base up to 4 at the top, that tells us the height of this smaller one must be 4. We can now compare this triangle to the bigger one. So with the big triangle, x starts at 0 here and goes all the way up to 6 when it reaches the corner. So from 0 to 6, the base of this one is 6. So compare these two bases. From 3 to 6, how many times bigger is this green triangle than ABO? Well, to go from 3 to 6, you can work out the scale factor of enlargement by doing the big side divided by the corresponding smaller side of the smaller shape. 6 divided by 3 is 2. In plain English, the big one is twice as big as the small one. So the base of the small one is 3, the base of PQO is 6. In the same way, if the base of the green one is twice as big, and it's mathematically similar, the height of it will also be twice as big as the height of the small one. And so the smaller one was 4, twice as tall as 4 would be 8. Because we've established that the big one is twice as big. 4 times 2 is 8. So the area of PQO, we need to remember the area of a triangle. The area of any triangle, whether it be PQO or not, is the base times the height divided by 2. Importantly, you need to divide by 2 when we're talking about a triangle. So the base is 6, the height is 8. We can then divide all that by 2. So 6 divided by 8, 6 times 8 divided by 2 comes to 24 square units. So that's our answer for the area of PQO. Part B, it says, in fact, QP is longer than it would be if the triangles were similar. So how does this affect your answer to Part A? So instead of QP being as it is, we're saying QP would be longer. So if I just go back to the original shape for a second, the original triangle, if QP was longer, instead of it being this green triangle, we'd be looking at something like this. It's not saying the base is any different, it's just saying it's taller. So if the base were the same but it was taller, I'm hoping you'll see that it's fairly obvious that the area of a triangle must be bigger then. If it's taller, it'll have a bigger area. And so, in terms of Part B, how does this affect your answer to Part A? The area would be bigger. The area of triangle PQO would have been larger. Question 20, we've got a distance time graph showing the journey of a toy train. We've got 4 different descriptions for the first 2 parts of the journey. We need to circle the letter of the correct description. So the first 2 parts of the journey are from here to 6 seconds, and then the flat bit here. And so if the gradient of a distance time graph is constant, if it's a straight line, that represents a steady speed. And so it's moving at a steady speed first of all, And then at this bit here, the distance isn't increasing or decreasing. If a distance isn't changing, it means something must be still, must be stationary. And so that's going to be B. So we need to circle description B. The first part, the yellow line, shows it moving at a constant speed. Then the green line, the second part which is flat, means it's stationary. Stationary is just a fancy word for staying still, not moving. So that'll be B to circle. Part B, we need to work out the average speed for the last 4 seconds of the journey. So it only goes up to 12 seconds. So the last 4 seconds of the journey is from 8 seconds all the way to that final 12 seconds. So we're looking at this part of the line. And so in the last 4 seconds, we can think, well, obviously the last 4 seconds is obviously 4 seconds long. But we can work out how far does it travel in those last 4 seconds. Basically the height. So this point here is at 4 meters. It's 4 meters away from where it began at, because here reads off at 4. At the end, at 12 seconds, it's gone up to 10 meters. So the distance travelled in the last 4 seconds, it's gone from 4 meters to 10 meters, and so 10 take away 4, it's travelled 6 meters. So if it's travelled 6 meters, in 4 seconds, then how far has it travelled in just 1 second? To go from 4 seconds down to just 1 second, what do we divide 4 by to get 1? Well, if we divide any number by itself, we arrive at 1. And so we can do 4 divided by 4 to work out how far it would travel in 1 second. And if we divide this side by 4, we need to do the same to the 6 meters. And so 6 divided by 4 would tell us that it travels on average 1.5 meters in 1 second. 1.5 meters in 1 second means 1.5 meters per second. In other words, that's the speed. So the speed would be 1.5 meters per second. Now you could think of this in terms of speed, distance, time, and a formula for speed, distance, time, in which case we can use the speed, distance, time triangle. So if you want to work out the speed, we cover it up and see what's left. We've got distance on top, time on the bottom. And so we could use this formula if you wanted to. So distance on top, it travels 6 meters in a time of 4 seconds. So 6 over 4, 6 divided by 4, would again give us 1.5. So 1.5 meters per second. Question 21. You need to work out 5.85 times 10 to the 6, all of that, divided by 1.3 times 10 to the power 2, giving your answer in standard form. This is where practicing on your calculator will pay off. So let's type it in exactly as it appears. 5.85. There is a standard form button, but I don't like using that normally. You can use it. I'd rather just use the power buttons. Either or, doesn't really matter, as long as you're comfortable doing it whichever way you'd prefer. So 5.85 multiplied by 10 to the power 6, close brackets. We're doing all of that divided by, open brackets, 1.3 multiplied by 10 squared, or we can do 10 to the power 2, whichever you'd prefer. Press equals, we'd get 45,000. Now in standard form, if you bear with me for a while as well, I'll explain how your calculator can do this hard work for you, but to get a number in standard form, the first part of a number needs to be between 1 and 10. So at the minute, 45,000 is quite clearly bigger than 10. So where would we put the decimal for this number to be in between 1 and 10? There'd be 450, 45. The decimal would need to go here, between the 4 and the 5. But with any whole number, you can imagine it being an invisible decimal at the end of a number. So 45,000 is the same as 45,000.0. And so the first part of a number will be 4.5. Then we multiply by 10 to a certain power. If it's a big number, 10 or more, it's a positive power of 10. If it's a small number, for example less than 1, it'll be a negative power of 10. 45,000 is a big number, and so it's going to be a positive power of 10. The way we find the power of 10 is we count how many digits are between where the decimal actually is and where the decimal would need to be for the first part to be between 1 and 10. That's where the decimal is, that's where the decimal would need to be. In between the two is 4 digits. And so that would be 4.5 multiplied by 10 to the power 4. So that's our answer. But a calculator can tell you this. So if you get 45,000, notice here we've got two leading numbers that are non-zero. So that can be thought of as being two significant figures. 1, 2. If you press Shift and Mode, standard form is a scientific way of writing a number. So we press 7 for scientific mode. And we have two non-zero numbers to begin with, the rest are 0. So if we type in 2 here, it will convert the answer for us into standard form. So the calculator will tell us what it is. It's 4.5 multiplied by 10 to the power 4. And that's the final answer in standard form, which I mentioned before. Now before you panic with your calculator just always giving you an answer in standard form, like this, if you're panicking how to get it back out again into a normal calculation, if you press Shift Mode, put it back to normal mode, 8 for normal, then press Mode 2. Mode 1 or Mode 2, either should do, but I think Mode 2 is a better one. So press Mode 2, and lo and behold, your calculator will be back to working as it was before, giving you the same outputs. So, well, that's it for question 21. 4.5 multiplied by 10 to the power 4. Question 22. We've got 4 possible outcomes of an experiment, which are A, B, C and D. We need to work out the probability of D. Now, what we need to remember is one of the laws of probability, and that is that the sum of all probabilities for all possible outcomes of an event will equal 1. So that's what we need to remember here. So that means that probability of A plus probability of B plus the probability of C plus the probability of D, all those added together, because it can only be one of these 4 possible outcomes, that'll equal 1. And so what we can do here is fill in this information according to what's been given to us. So we're told that the probability of A is 0.28. And so we can put this value in place of PA. Probability of A is 0.28. So let's just put that in. Now to look at the probability of B is 2PA. Now what that means, there's no instruction in between the 2 and the P. And so what that means is it's 2 lots of the probability of A. Why have I put P? So I think I'm getting a bit mad here. Didn't mean to put P, I meant to put 2. 2PA means 2 lots of the probability of A. But the probability of B, we can work this out directly now, because 2 lots of the probability of A, we know the probability of A is. So the probability of B is just double 28, well 0.28 I should say. So 2 multiplied by 0.28 would give us 0.56. And so we can again substitute this value for probability of B in place of P brackets B. So as I say, just replace PB with what PB is equal to. So little by little we're adding information to this question to make it solvable. So 0.28 plus 0.56 plus these two equals 1. So what we can do is neaten this up slightly by combining these two values. So 0.28 plus 0.56, we can just add these two together. And that comes to 0.84. So 0.84. Now, these two are equal. The probability of C and the probability of D are equal. And so because of that, we can say that the probability of C is the same thing as the probability of D. So what I'm going to do here, using this fact, is just replace C with D, because they're one and the same thing. So if that's the probability of D, then the probability of C is the same as the probability of D. So by swapping one with the other, I'm not really changing anything at all. And so what that means is I've got 2 lots of the probability of D, because one is the same as the other. So 2 lots of the probability of D, these two combined, that will equal 1. So this becomes 0.84. PD plus BD is 2 lots of the probability of D. Now what we can do is begin to solve the equation. This 0.84 is a positive thing. And so if we move this to the other side of the equation, we'll swap the side and we'll swap the sign. The opposite of plus 0.84 is minus the 0.84. And so 2 lots of the probability of D will be 1 subtract 0.84. So 1 subtract 0.84 would give us 0.16. And so we don't want 2 lots of the probability of D, we just want 1 lot of the probability of D. So that 2 we want to disappear. So that 2 is multiplying the probability of D. So if I swap it to the other side, it will change to the opposite thing. Opposite of multiplying is dividing. Basically, we're just halving both sides of the equation. So the probability of D will be 0.16 divided by 2, which you should find is 0.08. So that's our final answer for the probability of D. Question 23. Circle the identity, it says. Well, the identity has a special symbol. The identity has a symbol where it's a three-barred equals sign. The difference with an identity and an equation is an equation is sometimes true just for some values of x, whereas an identity means it's exactly the same thing and is always true. And so it's just a case here of circling which one is the identity. So it's the only one which has got the three-barred equal sign. So it's got to be this final one here. This is an inequality. That's an equation. The top one doesn't have any equal sign, so that's called an expression. This one here is the identity. So this is the one we need to circle. It's as simple as that. If you can spot a three-barred equal sign, that's known as an identity. That's just worth making a note of, actually. That is the identity symbol. Question 24. The value of a car decreases by the same percentage each year. So which graph shows this? Circle the correct letter. So one way to think about it is just to make up a percentage. Like, let's say it loses 20% of its value each year. If 20% or whatever is lost, that means there's always a tiny bit left. 100 take away 20, there'll always be a certain percentage left over. It'll never actually get to 0. That's just a random example. Even if it was 90% lost each year, there'd always be 10% left over. 100 take away 90 is 10%. Think of it in terms of real life. There's a website, I believe still, WeBuyAnyCar.com. And so We Buy Any Car means even if it's a 50-year-old car, it's always worth something. It's never worth nothing at all. And so this here goes down to literally 0 value. It can't be that one. This one goes down to 0. So it can't be B. C is just totally bizarre. C makes no sense. If we were to pick a certain time, let's say this was 2 years after you've bought it, or 3 years. This is saying that the value is two different things. The value is something down here, and it's something up here, so this graph just makes no sense whatsoever. So that one's just a case of what is going on. D is the correct one, and so D is the one we need to circle. So the value will keep decreasing and decreasing, but it will never quite touch 0. Because a car's always worth something, even if it's a matter of a couple of quid or 100 quid or whatever, even if it's just a scrap metal. So we'd have to circle D. It's always going to be worth something, so we can eliminate A and B. C is just bizarre. It's got to be D we circle. Question 25. We've got two different shapes, a rectangle and a T-shape, which is made from two different rectangles. What we need to do is to show that the rectangle and the T-shape have the same area. And so what we can do here is just consider the two shapes separately. So first of all, just think of a rectangle. So the area of a rectangle is a straightforward formula. The area of a rectangle is just the length multiplied by the width. And so it's 7 long, 7 up and down, so 7 long, x plus 1 wide. And so the area of this one is 7 multiplied by x plus 1, which we can either leave as factorized form, or we can expand it. 7 times x is 7x, and 7 multiplied by 1 is 7. And so the area of a rectangle is 7x plus 7. Now the T-shape looks harder, but it's not as hard as it may appear, because we can always consider a T-shape like this to be made up of 2 rectangles, like the question actually says. So if we just split it in half here, not in half, but split it into 2, then we can think of it as a top rectangle and the bottom rectangle. And so the second thing I'm going to do now is to think of the T-shape. So the top part of it again, if you think of the top part as being a rectangle, we can apply the same formula to work out the area of a rectangle as we did for the first rectangle. It's just going to be different measurements, but it's the same idea entirely. And so the top part, the area, will be the length multiplied by the width, and so 2 multiplied by 2x plus 5. Which again we can span out. 2 multiplied by 2x is 4x, and 2 multiplied by 5 is 10. And so the top green rectangle would give an area of 4x plus 10. Whereas, just to remind ourselves, the first rectangle here has an area of 7x plus 7. So now we can think of the bottom part of the T-shape, the bottom rectangle. Just colour coding it in a blue colour. And so the bottom part we can do in the same way. So for the bottom part, again it's a rectangle, so the area will be the same formula. So the area again is just the length of this blue one multiplied by the width of the blue one. So in this case, it's going to be 3 multiplied by x minus 1. And again, if we just expand these brackets, 3 multiplied by x is 3x, and 3 multiplied by 1 is 3, but because that's a minus 1, we'd get minus 3. And so the bottom part has an area of 3x minus 3. And the top rectangle, the green one, we worked out it had an area of 4x plus 10. And so the total area of a T-shape is the area of the top bit, which is 4x plus 10, added to the area of the bottom rectangle, which is 3x minus 3. And so we can simplify this expression down somewhat by grouping together the x's and grouping together the units. 4x plus 3x gives us 7x, and 10 subtract 3 leaves us with 7. And so the total area of the T-shape, we'd arrive at 7x plus 7, which is what we had for the first rectangle. And so this proves that the area of the rectangle and the T-shape are exactly the same. They're both, in terms of x, 7x plus 7. Question 26. We need to use a ruler and compasses. So it's a scale diagram where 1 centimetre represents 2 kilometres. And so again, this scale is in the relationship where one number is a 1, the other number isn't a 1. And so we can change from centimetres to kilometres, or from kilometres to centimetres, by multiplying or dividing by the number that isn't 1. In this case, it's for number 2. So to change from centimetres to kilometres it represents, we'd multiply by 2, because we're going from a small number to a big number, going that way. Or going the other way around, from kilometres to centimetres, we're going from a bigger number to a smaller number. So to change from the kilometres in real life to the centimetres representing that on the map, we divide by 2. And so we've got 2 different things with this ship. It's closer to port X than port Y, and it says it's less than 11 kilometres from Y. And so on this diagram, 11 kilometres, we can convert to how many centimetres that would be worth by dividing it by 2. 11 divided by 2 would tell us that's worth 5.5 centimetres on the map. So if it's closer to port X than port Y, what we can do is a perpendicular bisector of these 2 points. But what I'm going to do is get a ruler and then a compass, as the question asks us for, and set the compass width to 5.5. So we just widen the compass out to 5.5. So what this means is that from Y, the distance from Y is less than 11 kilometres. And so if we take a compass and put it on Y and do an arc of 5.5 centimetres, what it's saying is that the ship needs to be closer than this line to Y, so it needs to be within this circle. But again, if we keep the circle the same width, don't alter the width of the compass, and do exactly the same on the other side, where X is, like this, what we will have made is 2 arcs that cross above and below the line. So the only thing we need to do now is, with a ruler, to do a straight line through these intersections. So as you can see, I'm ever so slightly off there. It's not quite perfect, but it's probably worth you seeing. But you don't have to be perfect in the exam with constructions, but you need to be as accurate as possible. In theory, this should be a perfectly straight line going through both points. It more or less does, but as you can see, it doesn't quite. So anyway, I've done the perpendicular bisector of the line between X and Y. And so what we need to do now is to read the fact that it needs to be closer to X than to Y. And so, as I said before, it needs to be within this black circle on this side. But if it's closer to X, it needs to be on the left-hand side of this blue perpendicular bisector. So it needs to be towards X. If it was on the other side, it'd be closer to Y, which isn't allowed. And so, just to finish off, what we need to do is to make it clear that this is the region where the ship could be. And so we need to just label this R, as the question asks us to. But for the sake of trying to make it a bit clearer, I'm just going to colour in the region so you can see which side I'm referring to. If you're listening to me, it's obvious because I'm explaining as I go, but for people just flicking through the video and getting like a skim read of what I'm doing, this will be more obvious to them. So, and as well, it's a good excuse for me to practice my colouring in skills, which aren't great. So it does say label it R, so you have to do what the question asks us to do to get the full marks. So here we need to just label this R. And that's it for question 26. Question 27, the last question on the entire paper, and this is an awkward simultaneous equations one. So it revolves around two numbers. So first number and a second number. So let's just call the numbers A and B, or X and Y, just call them two different letters. So I'm going to say the first number, call it A. You can call it whatever you want to, really. The second number, let's call it B. And so now referring to this question, if I multiply the first number by 4, so if the first number's A, and I multiply that by 4, that's 4A. And add the second number, so plus the second, which is B, the answer is 32. And this second line, if I multiply the first number by 2, so in that case it'd be 2A, and then add the second number, so again plus B, the answer is 23. And so we've got two different equations to solve, and these two are called simultaneous equations. The objective with simultaneous equations is to eliminate one of the unknowns, whether it be the A or the B. In this case, what we do is we try and pick the unknown which has got the same numbers in front of it. Don't worry about the signs yet. The A's have got different numbers, 4 and 2, but the B's are the same. They've got one B on top and one B on the bottom equation. And so what I could do is the top equation take away the bottom one. If you did all of the top, take away all of the bottom, the top B, take away the bottom B, would leave us with no B's whatsoever, which is exactly what we're after doing. We want to make one of the letters disappear. Doesn't matter if it's the A or the B, but in this case it's easier to just get rid of the B. So let's do the top equation, take away the bottom. 4A take away 2A would leave us with 2A's. B take away B would leave us with nothing at all. Then the numbers 32 take away 23 would be 9. And so 2 lots of A is 9. We can divide both sides of this by 2 to work out what A is. That 2, which is multiplying the A, becomes a divide by 2 when we swap the side and swap the sign. If 2 lots of A is 9, 1 lot of A will be 9 divided by 2, which is 4.5. And so the first number is 4.5. We now pick either the top equation or the bottom to put this value for A back in. It doesn't matter which. Let's go for the bottom equation. So 2A plus B equals 23 is what it says. But 2A, we already said earlier, was 9. If 1A is 4.5, 2A would be 9. And so what we can do is replace 2A with a value of what 2A would be, which is 9. We've now got 9 plus B equals 23. And from this we can work out what B on its own would be. This 9 is a positive 9, so if we swap the side of it, we'll swap the sign of it. Opposite of plus 9 is minus 9. The final step is B will be 23 minus this 9, which will be 14. Therefore, B equals 14. So the first number is 4.5, the second number is 14. And that's question 27 done, and therefore the entire paper. I hope you found this useful in some ways. Do let me know in the comments if there's anything else you want me to go through. Come back to me in class with any questions you might have, and keep working hard and keep revising, and you'll get what you deserve in those tests if you work hard enough. Best of luck, and I'll see you soon.